Hello and welcome back to the shooting gallery tutorial for Ren'Py part 2, and let's just jump straight back into it, shall we? So in the last part of the tutorial, we had just finished creating some screens for our game where we have set up some background images as well as a cork gun transform that is following the mouse cursor around on the screen. In this part of the tutorial, we're going to add some targets to the minigame, and depending on how much we can get done in this part, we may also go ahead and animate them. Now, to make the script a little bit more readable, especially when you have a lot of variables, I like to group each of the variables that has to do with the same thing and then add a comment above that group to let you know what these variables are for. So in this case, we have a group of cork gun variables. So I'm going to go ahead and add a comment above that and say cork gun variables, like so. And then we're going to do the same thing for the rest of the variables as well. So the next thing we're going to do is to add some target variables. So we're going to create a few empty lines underneath here, like so. And then we can go ahead and add a comment straight away that tells us that these are going to be the target variables. So we're going to say target variables. So the first variable we're going to create is going to refer to a Sprite Manager object. And if you're not familiar with the sprite system in Ren'Py, I highly recommend that you visit the official documentation page of Ren'Py's website, as it has a lot of information about that. But basically, what a Sprite Manager does is it creates and manages a bunch of sprites, and these sprites are essentially images. And then when you want to show the sprites in the game, you simply add the Sprite Manager object to one of your screens. A Sprite Manager is really good to use when you have a lot of images that you want to show in your game, such as when you want to create a particle system, for example, as it was created to handle a larger amount of images at once. The sprite system in Ren'Py also has some handy callback functions that can be used, for example, to change the placement of each of the sprites on the screen in accordance to different user events. And for this tutorial, the Sprite Manager system is going to be very useful for our targets. So to create this Sprite Manager object, we're first going to create a variable that we're going to call target sm. And the SM stands for Sprite Manager. And then we're going to say is equal to Sprite Manager to create a Sprite Manager object from the Sprite Manager class. And this Sprite Manager object can take two different parameters. One takes a function that is going to run whenever the Sprite Manager object needs to update. And the other takes a function that is going to run when an event occurs in the game, such as when the user clicks with a mouse or taps on a key on the keyboard. In our case, we're only going to need the update function. So for that, we're going to say update is equal to target update. So now we're saying to the Sprite Manager object that it should run the target update function whenever it needs to update. And the update function of a Sprite Manager is usually run when the Sprite Manager has first been shown in the game, as well as when we are calling a redraw method of the Sprite Manager class, which causes the Sprite Manager to redraw itself and thus also update. And I will leave a link into the description box below where you can read more about the sprite system in Ren'Py. So the next thing we're going to do is to create a few variables that is going to set the zoom factor for each row of targets. So for that, we're going to create a new line, and then we're going to say target row 1 zoom is equal to, so the first row of targets are going to have a zoom factor of 0.5, which means that they are going to be 50% smaller than the original size of the target. So a value of 1.0 is going to be 100%, and a value of 0.0 is going to be 0%. And then we're going to do the next row. So we're going to say target row 2 zoom, and this row is going to have a zoom factor of 0.3, so they are going to be 30% smaller than the original size of a target. And then we're going to do the third row, so we're going to say target row 3 zoom is equal to 0.2, like so. And then we're going to create a variable that is going to refer to a dictionary that is going to contain all of the sizes of the different targets. And this is going to help us in various calculations later on in the script. So for that, we're going to create a new line, and then we're going to call this variable target sizes, and then we're going to create two curly brackets like so. And now, since this is going to be a dictionary, each item is going to have a key and a value. So the first key is going to be called top to refer to the top row, and then the value is going to contain a tuple So we're going to add 2 brackets, like so. And the original width of a target is 376 pixels. So we're going to write that. And now to determine what the target size is, depending on the zoom factor that we have given, we're going to multiply the width and the height by that factor. So for the top row, we have determined that the size is going to be half of its original resolution, which is therefore a zoom factor of 0.5. So we're going to say 376 times target row 1 zoom, like so. And then we're going to do the height. So we're going to say 455, which is the height of a target. And then we're going to say times target row 1 zoom, like so. And then we'll do the rest. So I'm going to add a comma after this tuple. And then for this item, we're going to create a key that is named middle to refer to the second row. And then the value is also going to be a tuple. And then in here, we're going to say 376 times target row 2 zoom. And then 455 times target row 2 zoom, like so. And then we'll do the last one, which is going to be the third row. So we're going to add a comma after this tuple. And then we're going to say bottom to refer to the last row. And then inside of this tuple, we're going to say 376 times target row 3 zoom and 455 times target row 3 zoom, like so. So now we have a variable that is referring to a dictionary that contains all of the sizes of the different rows of targets. So the last variable that we're going to create inside of the start label for now is going to refer to a list that is going to contain all of the target sprites that we're going to create. So for that, we're going to create a new line, and then we're going to say target sprites is equal to, and for now it's going to be an empty list as we're going to be filling it soon inside of a function. And the reason why we're creating a list to fill all the sprites with is so that we can easily and quickly access them when we want to make changes to them. So now, after we have created all of these variables, we're going to call a function that is going to help us to set up all of the sprites for the targets. So we're going to create a new line, and then we're going to say setup targets, like so. So this function is going to help us to create and place each of the target sprites on the screen. So now let's go ahead and go up into the init Python block and create this function. So we're going to create a few empty lines underneath here, and then go inwards once in the indentations, like so. And then we're going to say dev setup targets, like so. And the first thing we're going to do inside of this function is to create a few variables. And the first variable is going to determine the X position of the first target on every row. So for that, we're going to say target start X is equal to, and this is going to be 280 pixels, like so. But for your game, you can of course experiment with this value to see what works best for you. And the next few variables is going to determine the Y position for each row of targets. So the first one we're going to call target row 1 Y, and then we're going to say is equal to, and the first row of targets is going to be positioned at 37 pixels on the Y axis. And then the next one is going to be the second row, so we're going to say target row 2 Y is equal to 285 pixels, like so. And then the last one, target row 3 Y is equal to, and this is going to be 460, like so. And then we're also going to determine the amount of spacing that is going to be in between each of the targets. So we're going to say target spacing is equal to, and a good value for this I have found to be 100 pixels. The next two variables we're going to create is going to help us to animate the targets while they are in their idle state. And these variables are going to contain the amount of seconds that they should be down for or up for. And each target is going to have a randomly picked value that corresponds to the amount of seconds that they should be down for, but all of the targets are going to share the same amount of time that they should be up for. So for that, we're going to create a new line. And then the first variable we can call target down time. And this variable is going to refer to a tuple that is going to contain two values. And these values are going to be used in order to pick a random value between. So we're going to create two round brackets, like so. And the values that I have found works good for this tutorial is 0.0 and 2.0, like so. So these two values are going to be used in order to pick a random value from for each target. The next one we can call target up time. And this one is just going to be a simple float value. And for this I have chosen to go with 2.0. So each target is going to be up for 2 seconds once they have gone up. Next, we're going to create a for loop, which we're going to use in order to create and place each of the targets on the screen. And to do that, we first of all need a new variable that is going to help us to keep a track of which column we're currently in for the current row. So for that, we're going to say current column. And this is going to have the value of 0 to start with. And then we're going to create a for loop. So we're going to say for I in range. So we're going to use the range function in order to make this for loop iterate 12 times. So we're going to add 12 instead of that. And then inside of this function, we're going to first of all determine how many targets are going to be on each row. So on the first row for this tutorial, we're going to have 3 targets. And on the second row, we're going to have 4 targets. And on the third row is going to be 5 targets. So each row is going to have 1 more target than the last one. So in order to make this work, we're going to create first an if statement that is going to check if the current iteration of the for loop is less than 3. And if that is true, then we know that we still need to add more targets on the first row. But if it's false, then that means that we want to continue on the next row. So we're going to say if I is less than 3. And if that is true, then we're going to go ahead and create a target sprite on the first row. And to do that, we first of all need to create a transform that is going to make sure that the target image has the correct zoom property value according to its row. So for that, we're going to say target transform is equal to transform. And then we're going to say child is equal to. And here we need to add a path to the image that this transform should use as a child. So for that, we're going to add 2 quotation marks. And then we're going to say images target 1.4.png, like so. So that means that we're going to use the 4th frame of the target animation as the first image that is shown when we launch the game. And that is because they are all going to be down when the game first starts. And then we need to add a zoom property for this transform, which is going to make sure that the target image has the correct size according to its row. So we're going to add a comma after that. And then we're going to say zoom is equal to target row 1 zoom, like so. And that is because this is going to be the first row of targets, so we want to use the target row 1 zoom variable to set the zoom property. And then we're going to make sure that we are creating a new sprite that is going to contain this transform as a child. So we're going to create a new line, and then we need to make sure that we're adding the new sprite that we're going to create into the target sprites list so that we have easy access to all of the sprites. So we're going to say target sprites. And then we're going to make sure that we are appending the new sprite object. So we're going to say append. And then instead of this append method of the target sprites list, we're going to create the new sprite. And to do that, we're going to use the Sprite Manager object. So we're going to say target sm.create. And then we're going to pass in the transform as the parameter to the create method in order to make sure that the transform is added as a child to this sprite. So we're going to say target transform, like so. Next, we're going to create a new attribute for the sprite that was just created. And this attribute is going to help us to keep track of which current row that this sprite is in. And that is going to help us later on in the script when we need to be able to check for a target on a specific row. So we're going to create a new line. And then in order to access the sprite that we had just created to add an attribute to it, we're going to refer to the target sprites list and then grab the last item, which is going to give us the sprite that was just created. So we're going to say target sprites at the index of -1 dot, and then we're going to call this attribute row, and this is going to be 1 to refer to the first row. The next attribute we're going to create for these sprites is going to be one that is going to determine for how long the target should stay down for. And this is going to be a randomly picked value, which is going to be generated for each target, and that is going to be based on the values that we have given the target downtime variable. And you may think of the random function available in Ren'Py in order to do this job. However, the random function within Ren'Py is not able to generate a random float value, So in this case, we're going to have to import a Python module called random, which contains a method or a function called uniform. And this function will generate a random float value based on these two values. So to do that, we're going to go up into the first line of this init Python block. And then we're going to say import random, like so. And then we're going to go back down here. And then we're going to say target sprites -1 to grab the last item in the list. And then we're going to say dot down time, which is what we're going to call this attribute. And then we're going to use the uniform function from the random module. So we're going to say random dot uniform. And then we're going to supply the values from the target downtime variable. And to do that, we can simply refer to that variable. So we're going to say target downtime, like so. So now the uniform function within the random module is going to generate a random float value between the two values that we have supplied into the target downtime variable. So the next thing we're going to do is to position the sprite on the screen by using the X attribute that is available as a standard to all sprite objects. And to do this, we're going to create a calculation that is going to take into account the current iteration of the for loop. So we can go ahead and duplicate this line, like so. And then we're going to remove this section right here and say X instead, like so, to refer to the X attribute. And then to create the calculation, we're going to say target start X to refer to the start X variable that we created up here. And then we're going to say plus a set of brackets. And then instead of those, we're going to say target sizes. And this target sizes variable that we created instead of the start label is a dictionary, and the item we want to grab from the dictionary is the one that has the top key. So for that, we're going to add 2 quotation marks, and then we're going to say top. So now we're grabbing the value for the top key instead of the dictionary, and since this value is a tuple, we want to pick the item from that tuple that we want to use for this calculation. And in this case, we want the item that represents the width of the target, and that is going to be the first item. So we're going to add another set of brackets after that, like so. And then we're going to say 0 instead of that, like so. So this is going to grab the first value from the tuple that is paired together with the top key instead of the target sizes dictionary. And then after that, we're going to say times I, and then instead of these brackets, we're going to say plus another set of brackets, target spacing times I, like so. So how does this calculation actually work? Well, if we assume that the current iteration of the for loop is the first one, and therefore the I variable for this for loop is 0, then we're placing the sprite with the X position of target start X, which we have defined up here to be 280, which is where we want the first target on every row to be placed at. And then we're saying plus the width of a top row target times I. And since the I variable is 0 in the first iteration of the for loop, this calculation is going to result in the value 0. Because if we have a value and we are multiplying it by 0, we're going to get 0. And then we're saying plus target spacing times I, which is also going to result in the value of 0. So the resulting value from this entire calculation is going to give us target start X, which is exactly what we want, because the starting target on each row is going to be positioned at 280 pixels. But then as we progress into the second iteration of the for loop, the I variable is going to be 1, and these calculations right here are going to give us different values, which means that this target is going to be positioned more to the right in the second slot of the first row. And then we're going to position the target on the y-axis. So for that, we're going to say target sprites at index of -1 dot y is equal to. And for this, we are simply going to refer to the target row on y variable, which contains the y position for the targets on the first row. So we're going to say target row 1 y, like so. And then we're going to do the next row. So we're going to create a new line and then go inwards once in the indentations. And then we're going to say elif I is less than 7. And this condition is going to be true if I is equal to 3. Because up here we're saying if I is less than 3, then we're going to do all this code right here. But if I happens to be equal to 3, then this condition is going to be true and place the target with the index value of 3 onto the next row. And this is going to happen until I reaches the value of 6. So the targets with the index values of 3, 4, 5, and 6 are going to be positioned on the second row. And that of course equals to 4 targets. And now to create and position each of the target sprites on the second row, we can simply go ahead and copy paste this code instead of the first if statement into the second if statement, like so. And then we're just going to make sure that we are changing some of the code inside of here to make it work for the second row. So the first thing we're going to change is this target row 1 sum variable, which should say target row 2 sum, like so. And then we're going to change the row attribute for the sprite to say is equal to 2 instead. And then for the calculation down here, we're going to grab the target width from the middle row instead of the top row. So we're going to say middle. So we're grabbing a target size from the middle row from the target sizes dictionary. And then we're going to change this target row 1y variable to say target row 2y instead. Now, in order to make sure that each target on the second row is placed correctly on the x-axis, we're going to have to change this calculation just a little bit. So instead of saying that the target's width should be multiplied by I and the target spacing multiplied by I, we're going to multiply it by current column. So let's go ahead and do that first. So we're going to change this I to say current column, and the same for this one right here. So current column. And then after this last line right here, we're going to say current column plus equals 1. So now this calculation is going to work very similarly to the one we did inside of this if statement above. So if we say, for example, that the current iteration of the for loop has the index value of 3, which means that it's the 4th iteration, then we need to make sure that we are creating the first target on the second row. And in such a case, we want the target to be placed at the x position of 280 pixels. So this calculation is going to work correctly because the current column variable is going to be 0 at the 4th iteration of the for loop, but then in the 5th iteration, the current column variable has already increased by 1, which means that this and this is going to be multiplied by 1. And that is going to result in that the second target is going to be placed in the second column of the second row. And then for the third target, this variable is going to be 2, and so on and so forth. So this is going to cause each target to be placed correctly on the second row. And now we're going to create the third row of targets. So we're going to create a new line underneath here, and then go inwards once in the indentations. And then we're going to say elif I is less than 12. So this else if statement is going to be evaluated to true if the I variable is between the values 7 and 11, which is going to give us 5 targets to create on the third row. So to create the target sprite, we can go ahead and copy paste the code that we have inside of this else if statement above. So we're going to copy that and paste that inside of here. And then as we've done before, we're going to change some of the code inside of here to work for the third row. So instead of saying target row 2 sum, we're going to say target row 3 sum. And then for this row attribute, we're going to change the value to 3. And then on here in the calculation, we're going to change middle to say bottom. And then for the last one, we're going to say target row 3y, like so. Now, in order for this calculation to work correctly for the third row, we're going to have to reset the current column variable before we place the first target on the third row. So for that, we're going to create a new line just above this calculation, right here. And then we're going to say if I is equal to 7. So if this iteration of the for loop has the index value of 7, then we want to reset the current column variable to 0. So we're going to say current column is equal to 0. And we only want to do this before we place the first target on the third row. But for the other targets, we of course want them to be placed in the other columns. So in that case, we're going to say else current column plus equals to 1, like so. And now we can go ahead and remove this last line right here, as we've done the necessary changes to the current column variable up here instead. So now we've added 3 rows of targets, and each row has different unique attribute values. So the next thing we're going to do is to add some more attributes to these targets, but these attributes are going to have values that are shared amongst all of the targets. So we're going to create a few empty lines. And then we're going to make sure that we are in the same indentations as these if statements, like so. And then to create the other attributes for the sprites, we're going to do the same thing as we've done before, which is namely to access the last sprite created in the target sprites list. So we're going to say target sprites -1 dot, and this attribute is going to determine the direction of the idle animation of the target. So for that, we're going to say idle animation direction, like so. And this is going to have an initial value of up, like so. And that is because all targets should be down when the game first starts and then gradually animate flipping up. And then we'll create the next attribute. So we can go ahead and duplicate this line, like so. In this attribute, we're going to call current frame. And this attribute is going to be used to refer to the current frame of the animation. And this is going to have a standard value of 5, which is going to make more sense later on once we have started to animate the targets. And then we're going to need another one, so we're going to duplicate this line. And this one we're going to call animation time, like so. And this one is going to refer to how much time that has passed since we started to animate the target. And this is going to be 0.0 as a default value. And then we'll create another one, so we're going to duplicate this line. And this one we're going to call hit. And this is going to help us to keep track of if a target was hit or not. And the default value for this is going to be false. And then we'll create the last one. And this one we're going to call up time. And this one is going to be equal to the variable that we created up here called target uptime that decides on how long a target should stay up for once it has flipped up. So we're going to say is equal to target up time, like so. So now we have added all of the targets and the necessary attributes that we need for them. But before we move on with other parts of code, we're going to correct a small mistake inside of this code, and that is namely with this random uniform function that we have in various places. We can't just pass a reference to the tuple that we want the uniform function to generate a random value from. We need to explicitly tell it the values that it should use. And to do that, we're going to make sure that we're grabbing the values from the target downtime tuple. And to do that, we're going to add 2 square brackets after the variable, like so. And then add a 0 instead of that to grab the first value from the tuple. And then we'll do the second one. So we're going to say target downtime. And then we're going to grab the second value, like so. And this we have to do for the other if statements as well. So we can go ahead and copy paste this section. And then paste it down here, like so. And then in the third if statement as well, down here, like so. And now before we can go ahead and launch the game to see what this looks like, we're going to make sure that we're creating the function that we have defined inside of the target sprite manager right here. So we need to define this function before we can run the game, otherwise we're going to get an error. So we're going to go back up into the init Python block again, and then we can create this function underneath this setup targets function. So we'll create a few empty lines and then go inwards 1, 2 times, like so. And then we're going to say def target update. And inside of this function, we can go ahead and add a pass statement for now. And that is just so that we don't have to add any specific code straight away to this function, as we don't need it just yet. And then we also need to add one required parameter to this function, and that is the shown time base, and that is the time since the Sprite Manager object was first shown on the screen. And we can call this parameter or argument st, like so. And the last thing we're going to do before we can launch the game to see what this looks like is to add the Sprite Manager object to the shooting gallery screen. So we're going to scroll back down here, and then we're going to add this Sprite Manager just underneath this first line, which is showing the target background image. So we're going to say add target sm, like so. So now let's go ahead and save our changes and launch the game to see what this looks like. So now that we are back inside the game again, I have already gone into the minigame screen, as you can see, and we can also see that we now have a bunch of targets available and visible on the screen. And each target on each row is nicely placed and spaced between each other. But so far we haven't really done much with this screen, so the targets are just standing still instead of animating up and down, and we haven't implemented any functionality to be able to shoot them yet. So in the next part of the tutorial, we're going to make sure that the targets are animating, and then we'll see what else we can manage to do. So I thank you so much for watching, and I'll see you in the next video.